I hope all of you are doing well. My name is Shreya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Re-Level. Now, in this video, we're going to take all of it one notch higher and one level above and talk a little bit about enhanced ER model. Okay, so we have talked already about what the basics of ER modeling is and how do we really work on ER diagrams and what are the notations and the symbols that we need to work on. In this video, we'll talk about the enhanced version of ER models. So let's quickly get started. Now, the idea is that as the complexity of the data increased, right, in the late 1980s, it became more and more difficult to use the traditional ER model for database modeling. The traditional ER model is what we studied just now, and the idea is that the data became a little bit more complex with time. The relationship between the data became more complex with time, and as a result of which it became very difficult to use the same ER model for the database modeling. Hence, instead of just discarding ER model, we tried to introduce some improvements or enhancements to the existing ER model to make it handle complex applications better. So ER model was suffice and sufficient for the data which was very simple. But the moment you increase or you put complexity in data, the traditional model kind of fails a little bit and doesn't help a lot in database modeling. Hence, as a part of the enhanced ER model, along with other improvements, 3 new concepts were added to existing ER models. Okay, the 3 are generalization, specialization, and aggregation. So now what we'll do is we'll talk about all of them one by one in detail and understand what the overall idea is. But before going deeper into it, we'll first understand a few more terminologies which we are actually going to use. So let me show you on the screen here itself. Here we have generalization, aggregation, and specialization. Okay, so what we'll do is we'll first talk about another concept which will be about superclasses and subclass set. Now over here, first we'll talk about the concept of subclass and superclass before moving to advanced ER model. Okay, so we can say that superclass, right, is an entity, okay, that can be divided into further subtype. For example, consider the shape superclass. Now it can be divided further into triangle, square, and circle, correct? Now over here, what you will realize is that superclass basically has subgroups. These are all subgroups. Okay, these have the subgroups, and subclasses are the group of entities with some unique attributes, and subclass basically inherits the properties and the attributes of the superclass. Let me write this down for all of you. We usually say that over here, subclass over here are the group of entities, okay, not just a single entity. It may or may not be, but usually it is a group of entities with some unique attributes, okay. Subclass inherits the properties and attributes from superclass. So here in our example, triangle, square, circle are all subclass, okay, because they are a group of entities and they have all the common entities or attributes that the shape will have. If a shape will have a size, these subclasses will also have a size or a shape or a color, right? Okay. Now with this, we'll move on to the first part, which is generalization. Now, generalization is the bottom-up approach in which the two lower level entities combine to form the higher level entity. Okay. In generalization, the higher level entity can also combine with the two lower level entities to make further higher level entities. Okay. I'll give you an example. It's more like I told you a superclass and a subclass system, but the only difference is the approach, which is bottom up. Hence, entities are combined to form a more generalized entity. Hence the name generalization. In other words, subclasses are combined to form superclasses. Okay, let's see over here. It's like two subclasses basically combine, or two lower level entities basically combine to form the higher level entities. So using this, I formed this. So this is like a bottom up approach, right? And sometimes using this entity and using this entity, I can introduce another entity as well. Okay, that is what it says over here, right? In generalization, the higher level entity can also combine with the two lower level entities and make further higher level entity. Okay, you can see the example. For example, the savings and the current account type entities, right, can be generalized as an entity, with the name account can be created. Okay, so that is what we have, and it's a savings and current is a account. Okay, so it works on the bottom up approach. From lower level, we move to the higher level entity. Savings and current is a account. Lower level entities combined to form a generalized entity. Let me give you another example. Over here, we have car, okay, and we have truck, and we have motorcycle. These are all entities and also known as subclasses, and they can combine with the relationship is a and form the entity vehicle, which is the generalized entity for the lower level entity. And this is again a bottom up approach. Okay, so I hope this helps you to understand that this is a bottom up process in which the entities car, truck and motorcycle are present, and they are generalized to form a superclass called vehicle. Okay, and this is what is the idea about generalization, when you generalize an entity based on the lower level entities. Next is the process of specialization. Now the process of specialization is the exact opposite to the process of generalization. Okay, now it is a top down approach in which one higher level entity can be broken down. In generalization, we combine lower level entities to make the higher level entity. In here, it's a top down approach in which the higher level entity is broken down into lower level entities. Okay, in here, in specialization, a higher level entity may or may not have any lower level entity sets. It's possible. Okay, that means a higher level entity, when it's broken down, it may not have any lower level entity sets. And the example shown over here is very clear that in here we can have student, and a student can be a ex-student also, and a student can be a current student also. Okay, and it may happen that over here when you break it down, let's say you're taking a very latest picture. So when you will do this and when you define this, it's for two paths. It's for ex student and it's for current student. And it may happen during this process that every student is actually a current student. Okay, no student is an ex student because nobody has left the school, let's say in probably the last 1 year. Okay, so it may happen that this set is completely empty. And that is what it was talking about as well, that it may happen then when you break it down, it may not have any, it may have empty entity sets as well. In the same example also, if you say that truck, car and motorcycle is a vehicle, it's a bottom up approach. But this is what generalization is. Okay, but if I do the exact opposite and say that vehicles can be broken down into car, truck and motorcycle, that is just nothing but a top down approach which is for specialization. So it works both ways. Okay, and it's just the opposite of the other. So based on the use case, you identify which one do you require. Okay, now with this we'll take a look at one more idea, which is the concept of category or union. Okay, now relationships of one super or subclass with more than one superclass. So it's like a superclass's relationship with other superclasses. So it's like vehicle, house, owner. Okay, and the union of all the three. Okay, so basically how we represent the relationship of maybe one superclass or subclass with other superclasses. Okay, so in this case all these three looks out to be superclasses itself and the relationship is being shown. Okay, so owner, or what you can say is owner over here is basically the subset of two superclass, which is vehicle and house. Right? A vehicle and a house both belongs to the owner. Okay. Last, we'll talk about aggregation. Now, aggregation is the process when relation between two entities is treated as a single entity. Okay. So, you have two entities, you have a relationship, and all of it together is known as one entity. Okay. Now, in the diagram here, you can see that the relationship between center and course together is now acting as an entity which is having a relationship with another entity visitor. Okay, as a visitor, when they go to a coaching center, the center and the course are one thing for him or her, right, for the visitor. Now in a real world, see, if a visitor or a student visits a coaching center, right, if a visitor or a student visits the coaching center, he or she will never inquire about the center only, or they will not just inquire about just the course. Rather, he or she will ask or inquire about the both of them, correct? When you are, let's say you want to enroll for a maths tutoring and you go to a coaching center, so you ask questions about the coaching center also, right? And you ask questions about the course as well. You never just ask questions about one thing. So when you ask questions about all of them, right, you inquire about both of them are being treated as a single entity. Okay, so here center and a course will both be treated as one entity. Similar example could be, let's say, if I am a patient, right? A patient visits the hospital, correct? Now, over here, when a patient goes to the hospital, he or she inquires about the doctors, correct? And they inquire about the hospital facilities as well, right? Or let's say, instead of that, you write medicines. So in this case, both of them can be treated as a single entity, because whenever you will visit a doctor, you'll ask the hospital about the doctor as well as the medicines that you require. Okay, so here an entities or relationship between two entities and in the entire place can be considered as one entity itself, and that is what the process of aggregation is. Aggregating two entities, combining two entities to become a single entity. And these are the three things that were introduced that actually made easier to represent the complex relationship, represent the complexity of the data in the ER models. Okay, so earlier, which was very difficult to represent it, now with the evidence of generalization, specialization and aggregation, it became very easy. So let's just quickly iterate on what we did. First, we talked about generalization, which is a bottom-up approach. Specialization is a top-down approach. In generalization, you combine lower-level entities to make a higher-level entities. In specialization, you take a higher-level entity and you break down into lower-level entities. Okay, and in the last part is aggregation, where you combine two entities to be actually be treated and their relationship as well to be treated as a single entity, because to the outside world it will look as a single entity itself. Okay, so I hope with this you actually understand the enhanced ER modeling part as well. That's what the overall objective is, to learn through a way where you can visualize the overall idea, and it actually helps to understand the concept in a far easier and a better way, so that it's easier for you to work on complex data as well and not only with simple data. I would recommend for this, take a few examples on your own now as well. Try to see how all of it works, right? How can you really work with the data? What are the key things that you need to keep in mind, right? How do you derive the relationship for enhanced ER modeling as well as for basic methods as well, so that you get a fair amount of idea. All right. So thank you so much for attending this session. That's it for this one as well, right? And I will definitely meet you in the next one. Bye bye.